All about musical intervals. My name is Tiffany Q, and today I will be taking you through the basics and the more advanced aspects of intervals in music theory. If you are somewhat experienced in intervals, feel free to jump ahead to the various sections if you are looking for something in particular. There will be timestamps in the description box below for easier navigation. If you are completely new to intervals, do take each section of this video slowly or just watch the parts that you need to. I usually teach the contents of this video to my grade 5 students over a period of 3 to 4 lessons with plenty of practice in each section. So please don't be disheartened if you can't quite follow everything straight away. With that being said, let's get started. What are intervals? An interval is the distance between two notes as read on a musical stave. There are two main components of an interval. Number one, the interval number as calculated by reading from a stave. For example, a second, a third, a fourth, a fifth, etc. And number two, the descriptive word. Perfect, major, minor, augmented, and diminished. If you are doing a theory exam, the earlier grades might not require you to know the descriptive words. Identifying intervals. Number one, the interval number. The interval number is calculated by counting the distance of the two notes of the interval and the notes in between based on their position on the stave. If we have the interval C to E, for example, now that's highlighted in red down below, we count C, D, and E as a third because there are 3 note positions on the stave altogether, including the one in between, which is the note D. I'm going to point to it now with my cursor, and I'm going to show it to you in a bit more detail on the next slide. So if we have this interval, the interval is C to E, counting from the bottom note. If we look on the right-hand side, I have numbered all the notes of the interval and the one in between, which is D. And that is how we know it is a third. Here is another example. This time we have C to a B, and if we write out all the notes of C and B and all of the notes in between, there are 7 notes in total, so that would be a seventh. For interval distance, as we are only focusing on the position each note has on the stave, any accidentals will not affect this interval number. So if you look at this picture below, I have various accidentals written in to make it look very complicated. But when we are calculating the actual interval number, we don't have to take into account any of these accidentals. So in our minds, we can just get rid of them. So as you can see, a C to a D is still a second, despite the accent of the D sharp, etc. Notice how C sharp and D flat are the same pitch in the two intervals below. I'm going to draw your attention to the intervals I'm talking about. Number one, this interval, we have a C sharp to an E. And then the second one here, we have a D flat going to an E. Now, a C sharp and a D flat will sound the same because they are the exact same pitch. If you're familiar with the keyboard, I'm going to show you now here. This note here is a C sharp or a D flat. So if I play to you both of the intervals which sound the same, they will both sound like this. However, interval distance depends on how they are written on the stave. So C sharp to E will be a third because, again, we can get rid of all the accidentals and write out C to E with all the notes in between, and that would be a third. And in the second example, if we write out D to E, ignoring the accidentals, we get a second because there are 2 notes in total. Side note, if two notes are the exact same pitch, we call that a perfect unison. And those are some examples of that. The descriptive word. This descriptive word will give you a bit more detail in describing the interval. There are 5 main descriptive words that appear before the interval number when naming the interval. We have the words perfect, major, minor, augmented, and diminished. In order to solve which one it is, we will have to use a method. Now, for me, I like to use major scales and 2 interval equations to solve intervals. Now, I know that many other teachers would use other methods, such as counting the semitones, and then the other one is using a mixture of major and minor scales. Now, in my experience, my students often make a lot of mistakes with those other methods because the methods require a lot of rote learning, or they require you to think differently. For example, some of the rules don't actually apply to every single interval. So the method I like to use is the major scales and 2 equations because I find that it is the most consistent and the most accurate. Okay, firstly, we need to know this fact. In any major scale, the tonic note, which is the first note of the major scale, as the bottom of the interval, paired with any other note of the same major scale as the higher interval note, will give you either a major or a perfect interval. Take C major scale, for instance. The tonic, or the first note of the scale, is C. Provided that it is the bottom note of the interval, and any C major note appears as the top note of the interval, the 2nd, 3rd, 6th, and 7th intervals will give you a major interval, and the 4th, 5th, and 8th intervals will give you a perfect interval. This same rule applies to every other major scale. Let's have a look at the illustrations below. Here is a written out scale of C major, which has no sharps or flats. And here we have the bottom note of the interval being the note C, because it is a C major scale. And on top, the top note of the intervals consist of notes that belong to the C major scale. Now, if this is the case, we get major intervals or perfect intervals. 2, 3, 6, and 7 will be major, and 4, 5, and 8 will be perfect in every single case. Here are 2 more scales to demonstrate the same point. The first one here is the scale of D major, which has 2 sharps, F sharp and C sharp. The same goes here when we have D, the tonic note or the first note of D major, and any other note on top of it that belongs to the D major scale, we will get either major intervals or perfect intervals. If we study the bottom example, F major, which has 1 flat, and that's B flat, if we have F as the bottom note of the interval and any other note belonging to the F major scale as the top note of the interval, we will also get major intervals or perfect intervals. Once we understand how major and perfect intervals are formed, we can learn the 2 equations below and use them to solve other intervals. So the first equation here, let's start with the word major here, which I've highlighted for you. If you have a major interval and you raise the top note of the major interval by 1 semitone, we get an augmented interval. Now, if we go backwards and we lower the top note of the major interval by 1 semitone, we get a minor interval. And if we lower it again further by 1 semitone, we will get a diminished interval. the second equation. Now, if we start off with a perfect interval, and we raise the top note of the perfect interval by 1 semitone, we get an augmented interval, and if we lower it by 1 semitone, we get a diminished interval. Just to highlight the fact that the major equation, the top one, only applies to seconds, thirds, sixths, and sevenths, and then the perfect equation only applies to fourths, fifths, and eighths, or octaves. With this knowledge, I'm going to show you the different types of intervals that we can clearly see from the equations. So on the very left here, we have an interval. The bottom note is a G and the top note is an E. Because the bottom note is G, we will think G major. So on the right hand side, I have written out the scale of G major. G major has 1 sharp, which is F sharp. If we count the number, the interval number, or the distance between G to E, hopefully you can see that it is a sixth. I'm going to count it here. 1, 2, 3, 4, 5, 6. Now, because the bottom number is G, the bottom note is G, we are referring to the G major scale. And the sixth note of the G major scale happens to be E, which is the exact same note as the top note of the interval. Therefore, this interval is a major sixth. And we are going to refer to the major equation, the top one here, and I'm going to show you how the other intervals are created. When we raise the top note by 1 semitone, it will become an augmented interval. So if we raise an E by a semitone, we have to put a sharp in front of it, so it becomes E sharp. When we lower the top note by 1 semitone, it becomes a minor interval, so E flat. And when we lower the top note by 2 semitones, it becomes a diminished interval, E double flat. Now, when I'm talking about raising or lowering these notes by a semitone, the only thing we change here is the accidental. Because if we actually move that E, and for example in the augmented sixth, and raise it by a semitone, make it an F, it is no longer a sixth, it becomes a seventh, as we discussed very early on in this video. When we are greeted with an interval as such to figure out, we must first find the interval number. So we have this interval, A going to a D sharp. Counting the notes according to their position on the stave, A to D sharp is a fourth. This means we will have to refer to the perfect equation later, because the perfect equation only applies to fourths, fifths, and eighths, or octaves. So once we've established that's a fourth and we know we're going to have to refer to the perfect equation, the next step is to write out a scale of A major, since the bottom note of the interval is A. So here is a written out scale of A major. A major has 3 sharps, F sharp, C sharp, and G sharp. Notice how the fourth note here, which is circled in red, is a D. So the fourth note of the A major scale is a D, whereas the interval shown above is a D sharp. So now we have to do a bit of thinking here. If the interval had been A going to a D natural, then it would be a perfect fourth, because the note D exists in the A major scale that we are referring to. However, since the D has been raised by 1 semitone to become a D sharp, we can conclude that the interval is actually an augmented fourth. Have a look at the equation here. If we have a perfect interval, which would be A to D, and it's erased by a semitone, in this case D sharp, it then becomes an augmented interval, and this interval is an augmented fourth. One more interval for you. We have G flat going to F double flat. Counting the notes according to their position on the stave, G flat to F double flat is a seventh. This means we will have to refer to the major equation because the major equation applies to seconds, thirds, sixths, and sevenths. The next step is to write out a scale of G flat major since the bottom note of the interval is a G flat. So here is a scale of G flat major, slightly more complicated, just to throw in a mix there. G flat major has 6 flats: B flat, E flat, A flat, D flat, G flat, and C flat. So I've written out the scale here. Notice how the 7th note of the scale, which I've circled in red, is F, natural, whereas the note in the interval that they've asked us to figure out is an F double flat. This means that the note F, originally from the major scale, has been lowered by 2 semitones. And if we refer to this equation here, if we had a G flat going to an F, that would have been a major 7th because F exists in the G flat major scale. However, since it's been lowered by 2 semitones, you can see these arrows have gone back by 2 semitones, we can conclude that the interval is actually a diminished 7th. Writing an interval above a given note. The same principles apply to writing an interval above a given note as figuring out a given interval. You must have good knowledge of all your major scales, and you must understand the 2 interval equations. So I've put them there below again for reference. So here are some examples that I'm going to be going through. A minor 6th above the B, diminished 8th above the A flat, and a major 2nd above an E. If you'd like to figure this out yourself, you can also pause the video here and work these out. If not, I'm going to go straight into the solutions. So, a minor 6th above B. The first thing we're going to do is we're going to write out the scale of B major. So B major has 5 sharps: F sharp, C sharp, G sharp, D sharp, and A sharp. Now the 6th note of B major, which I've circled, is a G sharp. And from our equations, we know that a 6th will require us to refer to the major equation. Remember, major equations are used for seconds, thirds, sixths, and sevenths. If we had the interval B going to a G sharp, that would have been automatically a major 6th because the G sharp exists in the major scale. However, since they are asking us for a minor 6th in this question, we look at our intervals equation here, the major equation, and we see that if we lower the major interval by 1 semitone, we will get a minor. Therefore, when we lower the G sharp by a semitone, we get a G natural, which is the solution here. A diminished 8th above A flat. Okay, here is the A flat major scale, has 4 flats: B flat, E flat, A flat, and D flat. Now because they're asking for an 8th, we refer to the perfect equation because the perfect equation applies to 4ths, 5ths, and 8ths, or octaves. Now, a diminished 8th, here I'm reading down below, is a perfect 8th lowered by 1 semitone. According to the A flat major scale, a perfect 8th is going to be A flat to A flat. Therefore, a diminished 8th would be an A flat going to an A double flat. Remember, the only thing we can change about this whole semitone thing is the accidentals. So the flat will become a double flat. And finally, a major 2nd above an E. Well, we write out the scale of E major. E major has 4 sharps: F sharp, C sharp, G sharp, and D sharp. And we know that a major second, actually very simple, a major second is basically the second note of E major. And in this case, it is F sharp. And that is the solution here, E to F sharp. Writing an interval below a given note. For figuring out intervals below a given note, interval inversions are the best way to go. Figuring out intervals below a given note is always a bit more difficult than figuring it out above the given note. So this is the method I like to teach my students, because not only will it help with figuring out intervals below the given note, it's quite helpful for checking answers for other intervals too. Interval inversions are when we swap the top and bottom notes of the interval. So if we look at this example, in the first interval we have C going to E here, and in the second example we have E going to C. This is an example of an interval inversion where the top and bottom notes have been swapped. Here are some rules about interval inversions, and they will apply to any interval that is smaller than an octave. The interval numbers will add up to give you the number 9. Major and minor are opposites. Augmented and diminished are opposites. Perfect always stays perfect. So what I mean by that is, if we have a major interval and if we invert it, it will automatically become a minor interval. And if we start off with a minor interval, if we invert it, it automatically becomes major. Let's see some of these intervals in practice. The opposite of a major seventh is a minor second. So remember, the numbers have to add up to give you 9. So 7 plus 2 equal 9. And then major or minor are always going to be opposites. The opposite of a perfect fourth is a perfect fifth. The opposite of a minor sixth is a major third. The opposite of an augmented fifth is a diminished fourth. I have here illustrations of all the intervals and their inversions. You can pause this video if you'd like to double check to make sure that I'm telling the truth and these actually are correct. We can use this knowledge of inversions to our advantage, both when writing an interval below a given note and when checking our answers for any intervals question, as I mentioned before. Below are some questions which I will now go through. So writing a minor third below the F here, and writing a diminished fifth below this B flat. It's very similar to writing an interval above a given note, but we just have an extra step to do. So, a minor third below. Well, a minor third below a note will be the exact same note if it was the inversion, a major sixth above, because of the interval inversions rules that we just looked at there. So what we can do is we can actually find a major sixth above the F and then just drop that down an octave, and that will be a perfect minor third. So, major sixth is quite simple. We write out the scale of F major to find a major sixth above, and then the sixth note of F major is going to be the major sixth. So that note we find is at D. So that will be the same note if I just drop that down by an octave below that F, which will give us the minor third. And if you want to double check that for a second, if we have D here going to F, well, minor third. We know that a minor third is basically a major third that has been lowered by a semitone because of our equations. So if the bottom the bottom note is at D, we think D major. D major has two sharps, F sharp and C sharp, and the third note of D major scale is F sharp. So D to F sharp would be a major third, and if we lower that by a semitone, making it an F natural, that would be your minor third. And another example, a diminished fifth below a B flat. A diminished fifth below a note will be the same note an augmented fourth above it. An augmented fourth above a B flat is an E flat raised by a semitone, which is E natural. So I've written out the scale of B flat major here, and if we just check from our equations, because we're dealing with fourths and fifths, that is automatically our perfect equations. An augmented fourth is basically a perfect fourth raised by a semitone, so that's what I was talking about down here. If we raise the E flat by a semitone, we get an E natural. And that is going to be the same note a diminished fifth below B flat, which is here. Intervals with difficult notes or difficult accidentals. Sometimes we will be given intervals where the bottom note doesn't exist as a major scale, for example, D sharp or F flat. When we do these questions, we must transpose, that means raise or lower the pitches of the entire interval. So, I'm just going to show you here. That interval is a major third because the bottom note is C, so we refer to the C major scale, and the third note of C major is indeed E. Now, if I transpose that, so if I raise the notes by one semitone, and all I do is by changing the accidentals here, this will also give me a major third. Now, if I had lowered them, so in the third example we see flats in front of the notes, that is also a major third. Now, if I raised it by two semitones, which is this double sharps example, it's still a major third. And if I had lowered it by two semitones, here, the double flats interval, it's still a major third. So all of the above intervals are major thirds. This is because I've taken the first interval and transposed them in all sorts of ways, up or down one or two semitones. This works for intervals because I've kept the positions of the notes on the stave in each example, C and E. And what I do to one note of the interval, for example, raise it by one semitone, I do to the other note too. And that is the key. Here are examples of two questions. So they could ask you, identify this interval. Automatically you see that the C flat there is probably a little bit unfriendly. Now, if you're very good with your scales, you might know that C flat major does exist and has 7 flats, but let's, for the sake of this question, pretend that we don't know that. Here we have E sharp, write a major third above this note. Again, E sharp is an unfriendly note, and E sharp major doesn't technically exist, so this is a perfect example of a question that might be a bit more tricky to actually solve. We'll look at the first question first. So, step 1. Transpose these notes to something more recognizable. What we do to one note, we must do to the other. Therefore, an obvious solution in this case is raising both notes by one semitone just to get rid of both flats. What is left is a more accessible version of the exact same interval. So, here we have C flat and F flat, and it's a bit tricky to solve that, maybe at first. So what we can do is we can transpose. If we raise both of the notes by one semitone, we get C and F naturals, which is a much easier version of the interval. And because of transposition, how it works is that this first interval will be the exact same interval as the second one. So then we figure out the interval. We count the interval number being a fourth, C, D, E, F, 4 notes. Therefore, we shall refer to the perfect equation, if necessary. So the bottom note is a C, so we refer to the C major scale. Since the note F is the fourth note of C major, this interval is called a perfect fourth. Now, this question is slightly trickier. It'll just have an extra step. So, write a major third above this note. They're asking for us to write a note specifically above the E sharp. Now this question is slightly more tricky, as I said, because they are looking for a specific note rather than asking for the name of the interval. So step 1, we make the E sharp an easier note by lowering it by 1 semitone in this case, because if we do, it becomes an E, which is a lot easier. If you make that an E flat, lowering it by 2 semitones, I just feel like that's an extra step. Of course, it will still work out, but you want to find the easiest way to do it. Step 2, figure out the interval as normal. So figure out a major third above the new note here, which is the E. A major third above E is simply the third note of the E major scale, which is a G sharp here. Now, step 3. Now that we have a major third successfully from E to G sharp, we need to transpose this back to the original note. In order to get from an E to an E sharp, which was the original note, we are going up by 1 semitone. So what we do to one note, we must do to the other. Therefore, we will raise the G sharp by 1 semitone too, thus making it a G double sharp. So just to quickly recap, we were given an E sharp and they asked for a major third above. E sharp is tricky, so we changed that to an E natural. Then we found out a major third above an E natural, which is a G sharp. Now, because this is not the question that they're asking for an E sharp being the bottom note. If we go from an E to an E sharp, we go up by 1 semitone. Therefore, what we do to the bottom, we must do to the top. Or what we do to one note, we must do to the other in order to keep it as the same interval. So that G sharp will now become a G double sharp. Compound intervals. This is the final section of this video. Compound intervals are intervals larger than an octave. This interval is clearly larger than an octave. Here, the D to the F sharp. We know this because if we raised the bottom D by 1 octave and we placed it here on this second line, it would still be lower than that F sharp. And vice versa. If we lowered this F sharp by an octave and put it here in this space, it would still be higher than the D. To figure out a compound interval, we either lower the F sharp by an octave or raise the D by an octave. It doesn't really matter which one. Hopefully you can see that what we get is a major third when we bring the notes just closer together here. The D to F sharp or D to F sharp, the same interval. Therefore, the compound interval is called a compound major third or a major tenth. And all we do is we just add the number 7 to the smaller interval that we get. Works every time. Okay, here is another compound interval. We have a C to an A sharp. The first example we see is a compound interval from C to A sharp, which is bigger than an octave. The second example is bringing the notes closer together by lowering the A sharp by 1 octave. By figuring out the smaller and more manageable interval, we get an augmented sixth. Therefore, the larger interval is called a compound augmented sixth or an augmented 13th. Just add the number 7 again here. And that's pretty much it. So just for fun, here is a final challenge to end the video. If you can understand this question, then you have truly graduated from your intervals. So here it is. Now actually, all the information needed to solve this question is in this video. I've covered everything. So if you would like to work this out yourself, please feel free to. So the question is, write a major 14th lower than this given note. Major 14th, and we have here an F flat. So what I've done here is I've given a complicated compound interval mixed with a difficult note to work with, mixed with finding an interval lower than the given note. So let's get started. Step 1. Transpose the note to something easier to work with. In this case, I will raise it by one semitone, making it an F natural. So here is an F flat, a bit tricky. I'm going to make that an F, and that just happens to be raising it by a semitone. Step 2. Let's understand this compound interval. A major 14th is the same thing as a compound major 7th, because remember we always add the number 7. The question will be easier if we think of a 7th rather than a 14th for now. Now, because the interval is lower, we have to find the lower note, then we use our inversions. The inversion of a major 7th lower is a minor 2nd higher. A minor 2nd is a major 2nd lowered by one semitone, so refer to the major interval equation again. Therefore, a minor 2nd above F is a G flat, which will be the exact same note as a major 7th lower. If any of this is getting a bit confusing, maybe you can refer back to the earlier sections of this video. So, step 2, we find that a major 7th lower is a G flat here. Step 3, since it is a compound interval, we are going to lower the G flat by 1 octave. So here it is, lower by 1 octave in this picture here. And step 4, since the original note was an F flat and not an F natural, we will need to transpose everything back to the original interval. If we lower the F, it becomes an F flat, which was the original note. And what we do to one note, we must do to the other. Therefore, that G flat that we solved becomes a G double flat in order to answer the question. Thank you so much for watching this video, and I really hope that it was helpful. Be sure to check out my other music theory videos, which I'll be posting in the next couple of weeks.